Hello Year 5 and welcome to your maths lesson. Now I hope you guys got on okay yesterday. Today might be slightly more difficult where we look at comparing and ordering fractions, but we're going to use the same rules that we've looked at, the same concept with the pizzas and the number of slices, and we're going to see how we get on today. It's going to be a lot of noticing patterns, so make sure you take this lesson slowly and only do what you think you can do, okay? So we're going to skip the multiplication warm-ups today. I want to get straight into the division. So what I want you to do is I want you to have a go at working out the answers to these questions. So you might need to make sure your numerators or your denominators are the same. You need to think about whole numbers and anything that's going to be bigger than that whole number. And use your multiplication facts to help you. Okay, a lot of our division facts is based on multiplication knowledge and multiples and factors. So put a 5-minute timer on, pause the video and have a go. Okay, well, number 1 is 66, okay, because we know that 6 and 36 are common factors of the 6 times tables. To get from 6 to 36, we multiply by 6. Whatever we do to one number, we do to the other number. 11 times 6 is 66. Now, this one here, if we convert it so that our denominators were the same, we know to get from 10 to 20, we multiply by 2. So we multiply the numerator by 2. That gives us 50 over 20. So now our denominators are the same, and obviously we can see that 50 is bigger than 29. So that makes this fraction the biggest one. Now, if we've got two wholes here, and we're looking at 11, we know that 2 lots of 11 has got to be 22. But this symbol here tells me this number's bigger, which means it's got to be bigger than 22, because it's got to be bigger than 2 wholes. So I've gone for 24, but it could be anything that's then bigger than 22, because we know that 2 wholes would be 22 over 11, because it's 2 lots of 11. Now here I can see the common multiple between 16 and 8. Okay, 16 is in the 8 times tables and it's multiplied twice. So if we multiply both our numerator and denominator twice, we have the same numerator here, but we have different denominators. But we can see here that the denominator here for the 16 one is actually smaller. Although it's a bigger number, that means that that pizza has been split 14 ways, whereas this one's only been split 12 ways. So that actually makes this one the one with the bigger pieces. So each fraction bigger. Okay, so well done if you got those all correct. So we're just going to do a lot of practicing now about ordering our fractions. Okay, so it's looking at patterns and it's looking at multiples between numbers and seeing how we can convert them so that either the numerators or the denominators are all the same. Okay, so let's have a look and see what we notice about our numbers. Well, here I've got my denominators. This is 3, 9, 2 and 17. Now I've got odd numbers and even numbers there. And I don't see any match between times tables because the number's 17. But look at my numerator, it's got 2, 4, 5 and 20. Now I can all see that those are all multiples, okay, or they're all factors of the number 20. So I know here that I now need to make sure that all my numerators now match 20. Okay, so let's start with the first one. We think the numerators and the denominators. Well, we think the numerator, how do we get from 2 to 20? Well, we multiply that by 10. So we've got to multiply both of our numbers by 10, and that gives us 20 over 30. Then I need to look at the next one, and I'm looking at numerators still here. How do I get from 4 to 20? Well, I know 4 to 20 is multiplied by 5. So I've got to multiply both of my numbers here by 5. That gives me 20 over 45. Moving on to my next fraction again, I'm still looking at my numerator because that's the one we're trying to match. How do I get from 5 to 20? Well, I know multiply by 4. So I have to multiply both numbers by 4. That gives me 20 over 8. Now I need to put them in ascending order. Okay, so this means that whichever number on the bottom is the biggest, that makes that my smallest fraction, because my pizza here has got 45 slices, whereas this pizza here only has 8 slices, which means they're going to be bigger pieces and they're going to be smaller pieces. Now we need to remember that we have to write the original fraction down, not the versions we've converted to. These are here to help us work out which one's bigger. So we can see the smallest one there is going to be 4/9, okay, because that's got the most amount of pieces per whole pizza. The next smallest one's going to be the one cut into 30 pieces, so it's going to be 2/3. And then we've got 17 and 8. Well, we can see here that 17, okay, that's going to be a lot of teeny tiny slices of pizza, whereas this pizza here that's only got the 8 slices, they're going to be slightly bigger. So that last fraction there is going to be 5 halves, 5 twos, 5 lots of twos, okay? So I know that's a difficult concept to get your head round, but you need to remember the greater that denominator, the smaller that fraction is. So if I imagine I split my sweets 30 ways, but then I split these ones 45 ways, you're going to get less if I'm splitting it between more people. So the more people there are, the more pieces of pizza they're going to need, the smaller the piece is going to be because you're sharing it between more people. So I want you to apply that same knowledge to this one. Now I'm going to give you a clue for this one because I'm looking at this thinking, well, I can't match anything with my denominators because the number 19, that doesn't fit. But 5, 1, 30 and 60 could all go into the 60 times tables. But I don't want to have to multiply all of these to get all the way up to 60. But I can see here they've got 60 and 30. Now, because these are both even numbers, I could probably halve that. So I might think about dividing that one, thinking that maybe my numerators all need to be 30. So I want you to pause the video and have a go at converting them and then putting them in order of descending order. So descending order means I need to start with the biggest one. Okay, so pause the video and have a go. Okay, well, we already symbolised here that this 160 could actually be halved to 30. So we're going to go with 30 as our denominator. So let's halve that one and divide both numbers by 2. That gives us 30 over 16. Now that one's obviously going to stay the same. We then look at this one. Well, how do I get from 5 to 30? Because obviously it's the numerator I need to be the same here. So we need to compare my numerators. Well, to get from 5 to 30, or we'll do this one first, 1 to 30 times by 30, so multiply that. To get from 5 to 30, we're going to multiply by 6. So we have to multiply both the numerator and the denominator by 6. So that now gives us 30 out of 24, 30 out of 60, 30 out of 19 and 30 out of 16. Now we need to start with the biggest one. So effectively that means that we need the one that's got the smallest denominator because that means it's going to be the biggest piece of pizza per person. Now I can automatically see here that that's going to be this one. Okay, so it's going to be 60 over 32 because that's only had to be split by 16 people, whereas these have had to be split by 19, 24 and 60 people. So the next smallest one that's been cut up here is going to be the 30 over 19. So we can get rid of that one. Now, imagine my pizza this time round. This one's been split by 60 people and this one's only been split by 24, which means these people are going to get a slightly bigger slice of their pizza. So again, we're using that top fraction, okay, of 5/4. And then the last one left over is this one here, which is 30 over 60, which is the same as the half. So we're going to write the half down. Okay, so when it's in descending order, you're going from biggest to smallest. So imagine the alphabet, you write it in descending order, you write it from Z all the way to A. When it's the ascending order, ascending begins with A, like the alphabet, A, you start with A, B, C, and you work your way up that way. So we're going to have a go at now ordering these ones in ascending order. So ascending starts with A, so A, B, C, D. So we're starting with the smallest one, okay? Now, this one here is the odd fraction out for me. I'm going to ignore this one for now because if I think about this as a mixed number, 2 lots of 5 is 10. So this is actually bigger than just one whole. It's actually bigger than 2 wholes. So I'm going to think about these numbers here, and I've got 6, 12 and 3. Now I can't think about my numerators because I've got the odd number 19, but I know that 3, 12 and 6 are all factors of 12, so I can fit these now all in to the 12 times table. So I'm going to match my denominators. So let's start with this one. How do I get from 3 to 12? Well, I'm going to multiply by 4. So let's multiply both of them by 4. That's going to give me 16 over 12. This one's going to stay the same. This one over here, how do I get from 6 to 12? Well, we're going to multiply it by 2. So we're going to multiply both numbers by 2. That's going to give us 10 out of 20. Now this number's not changing, but this one's an odd one here, okay? If you think about it, 10 is double 5, okay? Which means that 10 over 5 is the same as 2 wholes. Now we've got 11, so we've actually got 2 wholes and 1 left over. Whereas all of these are all less than 2. So we know automatically that that one is going to be our biggest number, okay? So let's match these ones here. So we've got 16 out of 12, 19 out of 12, and 20 out of 12. So we need to pick the smallest one. So the smallest one is going to be the one that's had to be split more ways, okay? So we've got the biggest one there, so we can forget about the 11/5 one. The next smallest one is going to be this one, okay, because this one here has been split 16 ways, okay, so this has now got the smallest number of pieces, so we can get rid of that one. The next one that's got the next smallest number of pieces is the 19, okay, so 19 out of 12, so we can see we've gone from 16 to 19, and then the next one we're going to go to is 20, and that's going to be 10 over 6, okay, and then obviously our last one here is going to be 11/5, but obviously that's bigger than 2, okay. So we've now put those in ascending order. So we've started with the smallest one and we've worked our way up to the biggest fraction. Okay. So I want you to now have a go at doing the same thing. So the same thing we've been doing on all of the other slides. So think about, can you find a common denominator or can you find a common numerator? And is there a trick one in there that's going to trick you up? I'll give you a clue. There is one number in there that's less, that's actually a proper fraction. So 3 of them are improper fractions and one of them is a proper fraction. So pause the video, see if you can spot it and try and work out how might we answer this question. Okay, so I'm going to match it. So I've got 40 as my numerators because all these numerators here can go into 40. They're all factors. So I think, well, how do I get from 5 to 40? I'm going to multiply it by 8. I'm going to do that to both my numbers. The 44 over 40 is going to stay the same. This one here, or 20, how do I get from 20 to 40? I'm going to multiply by 2. So I need to multiply them both by 2. That's going to give me 50 out of 40. So far I've matched my denominators so that they're all the same. Bar this one. Why have I not changed this one over? Okay, this one's a proper fraction. This is not top heavy. The numerator is smaller than my denominator, so I actually don't even have a whole lot of 11s yet. Here I've got more than one whole 5. Here I've got more than one whole lot of 40. And here I've got more than one whole lot of 20. I don't have a whole here. This is a proper fraction. So this already is going to be my smallest number because it hasn't gone beyond being bigger than a whole. Okay. So that's going to be my first number in there. So if I then match all of my original numbers, looking at my denominators or my numerators, I need to start now with the smallest one. So we've gone from 44, from 50 to 56, okay? So this one here is technically going to be bigger because I'm going to get more pieces, and then we work our way across. Again, remembering to use the original fractions that we started with. So well done if you spotted that one there, because you know if you've got 11 pieces of pizza there, and you've only eaten 10 of them, you've still got 1 piece left. So you haven't even eaten the whole pizza. Whereas here, this pizza was cut into 5 pieces, and someone ate all 5 pieces and an additional 2 pieces. So we've gone beyond whole lots of our pizza here other than this one. So well done if you spotted that one. Let's have a go at a quick problem solving question. So Rosie and Jack each have 3 identical chew bars. Jack divides his bars into 4 equal pieces. So each one is 4, 8, 12. Rosie divides each of her bar into 2 equal pieces. So hers are 2, 4 and 6. But she also eats 5 pieces. Now Jack says that we've both eaten the same amount because we've both eaten 5 pizzas. Pause the video and have a think. Why is Jack incorrect, and can you explain to me how? So maybe have a go at drawing your bars as bar models and shading in the parts they've eaten and see if you can explain why he's wrong. Okay, so let's put them into bars. So each bar was split into 4 and Jack ate 5 of them. So altogether he's got 12 different pieces and he's eaten however many he's eaten. Rosie's only split hers into 2. So she's got 6 pieces from her 3 bars. So Jack's eaten 5 pieces of his, and left over, he's got 7. He's got 7 pieces left over. Whereas Rosie ate 5 pieces, she was only left with a half, okay? So if we think about then converting and comparing these, let's look at our fractions. So we've got 7 over 4 and 1/2. Now, I can see a common denominator here if I change this one to 4. So we need to think, well, how do we get from 2 to 4? We multiply it by 2. So let's multiply both those numbers. That's going to give us 2/4. Now, both of our denominators are the same, so we need to look at our numerators. Now, obviously, this one here is 7, which means it's much smaller pieces, whereas here, Rosie's only got 2. So that actually means that Jack has more pieces left over because he's got the additional leftover pieces, okay? So in actual fact, Jack has actually got more left over than Rosie does because she's eaten the majority of hers left over. She's only got 1/2 left, whereas Jack's got more than half of what he started with, okay? So now that I've blown your brains probably beyond oblivion, have a go doing questions 5 to 8. Now this is the same worksheet from yesterday, but you shouldn't have finished these questions because you were only asked to do questions 1 to 4 yesterday. So if you have done them and you think you've made some mistakes and now you know how to do them, then by all means go back and correct them. If you didn't have a go at those last few questions yesterday, then please have a go at doing questions 5 to 8 on your worksheet. Go back and pause the video if you get stuck at any point in time, but remember, always convert them so that either your denominators or your numerators are the same, and that will help you work out which one's bigger and which one's smaller. Okay? Good luck, year 5.